Hello, and today's lesson is looking at mineral exploration. So we're going to start with the idea of different scales of surveys to go out and find different mineral deposits, because obviously we can't extract them until we've actually found the things. And then we'll look at the different survey techniques in turn. So let's start off with the scale of surveys. So what we're looking at mainly here are remote surveys to start with. And these have the benefit of covering large amounts of data or larger amounts of data at different scales. So we can have satellite data, and these obviously cover the widest area. Or you could have aircraft surveys, which would cover a slightly smaller area, still wide area, but they could be potentially weather dependent or um, perhaps slightly cheaper initially, because obviously sending a satellite up is really expensive, but then a satellite will cover a huge amount of area very quickly. So it's sort of an intermediate step. And then you have ground-based surveys. And these are going to cover the least area, but potentially be the most detailed. But because they cover a small area, they're going to have a relatively high cost. Sending people on the ground out to deserts or mountainous areas is always going to be a bit more difficult. So these are potentially going to be quite cost effective. So you have a low cost per unit area, but they are going to be potentially less detailed, so that you have slightly less confidence in what is it showing you, but then they can cue you in to then go use more and more detailed survey techniques as you start finding areas of interest. So let's have a look at some survey techniques. First one then is IR spectroscopy. So this is a form of remote sensing. So it can be done by satellite or aircraft. So different minerals emit infrared radiation at different wavelengths. And so this can be used to identify geology or minerals. This is going to be particularly useful in places like deserts, where it is not covered up, and potentially less useful in jungle or highly vegetated areas. However, you get different plant communities change with geology, and you can identify that from IR spectroscopy. So you can even say, oh, we've got a change in the type of dominant tree in this area. So perhaps that's because there's a change in the bedrock underneath. So you can use it in a slightly more indirect way in those sorts of situations. The next one then is gravimetry. So gravimetry is again a remote sensing method. So this again is satellites or aircraft. And the idea is, as your satellite up in space or aircraft, obviously a lot further down than this image would suggest, so it's usually just some sort of commercial aircraft that's got sensors attached to a wing or something like that. As they fly over the Earth's surface, you are going to have areas that are much more dense, so perhaps a hidden batholith of igneous rock in amongst sedimentary rocks. Let's do that color. So we've got like layers of sedimentary rock around it. Perhaps we've got a bit of a contact metamorphic region around our batholith. This is going to be our most dense. And therefore affect the gravity. So as we're flying along, we'd say, oh, gravity's fairly normal, fairly normal, fairly normal. And then there'd be a dip or a spike in the gravimetry. So sensed gravity based off of the density and therefore mass of the underlying geology. And this is really useful for finding those igneous batholiths that are hidden and finding the boundaries of them, and then finding these metamorphic regions around it, which are really valuable for hydrothermal vents. So this is really useful for that kind of investigation, sedimentary. Okay, so next one then is magnetometry. Bit of a mouthful, that one, isn't it? So this is where we use magnetometers to, sorry, this again is a remote sensing, typically from aircraft. And we look for geology with a lot of magnetic influence. So here's our aircraft with our sensor on it, flying along above the Earth's surface. And we might have an area of iron-rich rocks. And iron is magnetic. So this might be magnetite, which is a very high concentration of iron oxide. So it's a good iron ore. And that will be surrounded by our country rocks, perhaps, or sandstones and silts and stuff like that. It's all our sediment. It's like sandstone, siltstone, something like that. And as we're going along, we find that our magnetic field being detected, there'll be a sudden reversal or change in the magnetic field around the magnetite. So change in magnetic field. Okay, and it'll affect other sort of magnetic stuff as well. We'll do this. So ores of tungsten and cobalt will also have this effect on the magnetic field.